Okay, hi girls. So you are working your way through fuels and heats of reaction. And I'm going to start and take a look at a couple of videos now in the next little while about naming. So this is the section I told you not to do by yourself. This is the section I'll go through with you through videos. Again, girls, you're in the lucky position that you're in fifth year. If you don't understand something or you're having difficulty with something, do your best with the homework. Come and let me know by all means, but no need to panic because we will see each other. If worst comes to worst and it's not this year, it'll be next year, and we have a whole year to plug any holes that you think you have. Okay, and every fifth year is in the same group, and they're all going to be stressing the same about getting courses finished and completed. Allowances will be made, I'm sure, and we're already seeing allowances being made in terms of orals for the sixth year. So you're going to see similar stuff have to happen for you girls. So please try not to stress too much. And my big fear with me doing these videos is that you think this is it, and if you don't get it this time, you're never going to get it. If you're still struggling with this or the naming or something in terms of water, we'll assign classes next year in terms of revision. We'll look at timetables, we'll find ways around it, and we'll sort you out. Okay? But for the main part, this is what I'd normally do in school. Now, normally I'd have little models that you can build. In the rush to leave school, never even thought about taking them. To be honest with you, thought I'd be back this week. It never entered my head to take them. And I know that the school was open last week, but as you know, girls, I have a toddler, my husband's working, so there's no way of me going or taking the toddler out. Because that would be the wrong thing to do, seeing as children are vectors, etc. So just in case, I don't want to be putting anybody's lives at risk by me going to get some models for you that I'll be able to use with you next year. Okay, so let's take a look at naming. If you take a look in your textbook on page 345, they have a list of names for you, and they're all alkanes. So what does an alkane mean? So an alkane is a family. So for example, my family name is Masterson. Okay, what can you tell by that name? Well, by the name Masterson, you can tell one or two things. One, you can tell that name is a Scottish name if you Google it. So my ancestry may be Scottish, though all the family I know are Irish. But also, you can tell who I might possibly be related to. So if you had no life or no time, God love you, and you decided to go onto Facebook and you decided to try and stalk me for some unknown reason, and you stalked that name Masterson, you would come up with all the hits of people who have the surname Masterson, some of whom may be my relatives. Does that make sense? So that name tells you who belongs to who. And in this branch of chemistry, you're taking a look at organic chemistry, we have very similar systems. So we have a list of families that belong together. So the first family you're going to meet is the alkane family. Okay? And how I'll know that somebody is an alkane and belongs to this particular family is that their name will end in ANE. And if their name ends in ANE, I will know that they belong to this particular homologous group. You will have had a definition at this stage in your copies about what a homologous group is. So a homologous group is a family group of compounds that all share some common traits. Okay, and the common traits that all of this family share is that they all have single bonds. So the first member of it has one carbon, and it has 4 single bonds off that carbon, and they're all surrounded by hydrogens. And the first member of that group, or the youngest or smallest member, is methane. It's a gas, you already know, I would think, from general knowledge. It's a gas that's normally associated with the back end of a cow, and that's how you might know about it, and it has some responsibility in terms of global warming. Okay, the second member of this family is CC, and it has 2 carbons, so it's a little bit bigger. In fact, it's almost twice its size, and they're surrounded again by all single bonds. So you'll note every single bond here is a single bond. That is one stroke, one line. What does each single bond mean? It means that we're sharing one pair of electrons. So carbon is sharing an electron with this hydrogen, and the hydrogen is sharing its electron with that carbon. And the same here, and the same here, and the same here, and the same here, and the same here. A single bond indicates that we're sharing one pair of electrons. Second member in this family is ethane. Okay. Third member then is 3 carbons in a row, and we're surrounding them with hydrogens. Now, what do I mean by surrounding? What I mean is that every carbon has 4 bonds off it. And that line isn't in a very good place, it should be there. Every carbon has 4 lines off it. So 1, 2, 3, 4, 1, 2, 3, 4, 1, 2, 3, 4. And wherever there's spaces all around the edge, they're filled in with hydrogens. So what can I tell you about this family? Well, this family of alkanes are made up of carbon and hydrogen only. So there's only carbon and hydrogens if you're an alkane. You're made of a carbon that has 4 bonds off it, and they're surrounded. And the big word for this family is saturated. And the word saturated is associated with the word alkane. And the reason they're called saturated is because there are no spaces in these compounds. So as you can see, every carbon is full, all of its 4 electrons are accounted for, and there is no space for anything else. So if I'm a bromine and I want to join up here, I have to get rid of one of these hydrogens. If I'm a chlorine, an iodine, they would be the normal things that would come along. If I want to change anything, it's a substitution type of reaction that I must undergo. And again, a lot of these words you're going to meet again next year with me when we take a look at more detailed organics. Any of these compounds are going to undergo a type of reaction called substitution. So I urge you to think about, what do you understand by the word substitution? So if we think about it in terms of sports, for example, if I'm on a soccer pitch, which I don't see happening anytime soon, but if I was on a soccer pitch and I was playing poorly or I hurt my leg, what happens? I'm taken off and somebody is put on in my place. That's a substitution. Okay? A substitution here means the exact same thing. I take one of those hydrogens off and I put something else on there in the place. That's the only type of chemistry that this compound as alkane can do. So the only type of reaction it can do is called a substitution reaction. So the first part of this, girls, is before you go anywhere, you're going to need to know 8 of them. So there are 8 on your course. So methane, ethane, propane. And if I have 4 carbons is the next one, it's butane, pentane, hexane, heptane, and octane. Okay, so that's 1 carbon, 2 carbon, 3 carbon, 4, and I'll write them in here, 4, 5, 6, 7, and 8. All right, so what do you need to do now? So the first thing you need to do before you go anywhere with this particular chapter is a couple of things. One, you need to draw into your copy the structures of methane right the way through to octane. So that's the first thing I'm going to ask you to do. Take a picture of your work and submit it as part of the assignment. So that's going to be Monday's job. Okay, Monday's job is going to take a look at getting methane all the way to octane. Now, all I can do is say to you one thing, girls. If you do not learn this at this point in time, you are going to struggle with the rest of the chapter. Okay, so if I can urge you to do one thing for me for the whole week, if you're only going to do one thing for me for the whole week, let it be this, and learn those 8 names and those 8 structures. Okay, and learn them old-fashioned way off by heart. So 1 carbon's methane, 2 carbons ethane, 3 carbons propane, 4 carbons butane. You need to be able to know it really, really, really well. Okay, once you've that part of it done, then the second part will be to take a look at naming structures where there's some substitution after happening. Okay, so where, for example, this hydrogen has been taken off and something else has been put in its place. There's been some sort of substitution, and how do I name it then? How do I tell you that that is not regular propane, it's propane that has something unusual here? Okay, and there's a little set of rules, and they're very easy to follow. And once I've done a couple of videos there, I will say what he's done in his book is very nice, very neat, very easy to read. Okay, and I'll do a few more examples and assign you examples. Your first job, though, is going to be to learn those 8. Okay, so I'll leave that with you and we'll talk again soon.